Hello, good day, good evening, good morning, depending on where you are. My name is Wayne Glines, and I'm the president of the Herbert M. Parker Foundation, and I'd like to welcome you to the Spring 2021 Parker Lecture. Before we get started with our lecture today, I'd like to take a few moments to tell you a little bit about Herbert M. Parker and the Parker Foundation. Herbert M. Parker was born in Britain and in the early 30s became a British medical physicist who pioneered medical radiation therapy and radiation safety. In 1938, he migrated to the United States to continue his work at Swedish Hospital in Seattle, Washington. In 1942, he was recruited to help establish health and safety programs for the Manhattan Project, first at Oak Ridge, Tennessee, and then 1944, he was expressly recruited and brought to the Hanford site to help develop the health and safety programs at the Hanford site. Parker was a pioneer of the modern field of radiation safety. His procedures and protocols developed at Hanford have been adopted throughout the world. Amongst his other accomplishments, Parker is known for introducing the Roentgen equivalent physical, which led to the rad and the gray, and the Roentgen equivalent biologic, which led to the REM and the Sievert. Following the Manhattan Project, Parker developed and managed the Hanford laboratories, which later became Pacific Northwest National Laboratories. Following his death, the Herbert M. Parker Foundation was established in 1987 as a nonprofit organization, and it was created to honor and perpetuate the high ethical and scientific standards of Herbert M. Parker. The remaining endowment funds were transferred to the Washington State University Foundation in 1997 and established a partnership with the Tri-Cities campus. The Parker Foundation supports scientific and educational activities to promote academic programs and public understanding of science and technology. Our activities include lectures and seminars, such as our lecture today. We provide academic scholarships. We've also been deeply involved in the Hanford History Project, which is an oral history project for people who worked at the Hanford site. We've also established educational collaborations with the Tri-Cities campus and with Columbia Basin College and the Delta STEM High School. Additional information can be found at our website. You don't need to write this down right now. I'm included the address. This web link is included in the chat room comments for this broadcast. Our lecturer today is Mr. David Allard. He is currently the director of the State of Pennsylvania Bureau of Radiation Protection, where he serves as the technical lead on norm and T-norm issues. He received his Master of Science degree in Radiological Sciences and Protection from the University of Massachusetts Lowell's Department of Applied Physics. He is certified by the American Board of Health Physics. He's a fellow of the Health Physics Society. He's a past chairperson of the Conference of Radiation Control Program Directors, and where he has served as liaison to the NCRP for the last 15 years. I'd like to give a special thanks to the Washington State University Tri-Cities and Northwest Public Broadcasting for all their help in putting together this broadcast. Special thanks go to Kelly Slocum, Megan Murray, and Dave Fossler at the Tri-Cities campus, as well as Tom Hungate and Matthew Kawamura for Northwest Public Broadcasting for their help in putting together this broadcast today. Additional information can be found again at our website. Alternately, you can send me direct questions or comments about the Herbert M. Parker Foundation at the address on the screen. Again, I've put this information in the comments, so you should be able to look there. Before I introduce our lecturer today, if you do have comments or questions during the course of the lecture, please type them out on the screen or on the comments section of the YouTube broadcast, and we'll try to get to as many of them as we possibly can at the end of the lecture. With that, I'd like to welcome and introduce our lecturer today, Mr. David J. Allard.
Can you hear me okay? Okay. Oh boy. Matt, can you hear me okay? Matt? Wayne, can you hear me?
I can hear you. It's a sound a little broken, but I can hear you.
Okay, I'm gonna shut my video down. And is that better? Better?
The sound is better.
Okay, good. I'll leave the video down then. Okay, good. I'm just gonna go to full screen here, and we'll take it from there. Okay. There we go. Okay. Great. Well, Wayne, maybe Wayne, if you could shut your screen down, or there we go. Okay, I got it. Okay. Well, Wayne, thank you for the introduction, and thank you so much for the invite. I really appreciate all your help in getting ready for this, and Matt and Megan, I really wish I could be out in the Tri-Cities with you folks for this lecture. I have a lot of good friends out there. I'm just going to rattle off a few names: Kathy, Earl, Daryl, Sergey, Ron, Matt, Dan, just lots of good friends and colleagues out in the area. So this is a, uh-oh. I can't advance. We try these things and, okay, let me try again. Slideshow. Okay, good. Okay. Quick disclaimer. Sorry about that, folks. These virtual meetings are crazy. Just quick disclaimer, opinions are myself. We're not promoting anybody. I have no conflicts of interest. And again, I want to thank Wayne and all the folks, the trustees and the foundation for this really great honor to give this Herb Parker lecture. I did not know Herb. I was just getting in the field in the mid 70s, and probably may have crossed paths with Herb at a Health Physics Society meeting, but did not get to meet Herb. But do know of all his great work, and I'll be focusing on a bit of that during this lecture. Clearly, as Wayne just explained, Herb was a luminary medical physicist back in the UK, came to the United States to work in Seattle, quickly recruited into the Manhattan Project, and really was one of the founders of the profession of health physics. And here's a group picture, courtesy of Paul Frame in Oak Ridge, with some of his colleagues, some of the founding members that first called themselves health physicists. So today, I just want to, this evening, I just want to go through, I've got a number of slides. Some of these I'm going to go through rather quickly. We're going to be crossing continents. We're going to be crossing, time over a century of work to kind of recap some of the early work with radium, what that work led to as far as current medicine and industrial practices. And just briefly on the front end of this, I just want to, because there may be some non-health physicists in the audience, just kind of describe some of the regulatory structure that Herb Parker very much developed. There were no regulations back in the 20s, 30s, 40s. It really wasn't until the 50s, 60s that all of the recommendations that came out of the national and international organizations became codified for the states and federal government. So then I wanted to answer this question, and I always like to start a talk with a question: radium, miracle or menace? And I hope to be able to answer that at the end of this. So just very quickly, here in the Commonwealth, we have a very broad program, a lot of old industrial sites. We produced actually a lot, as you'll see, much of the radium in the early part of the 20th century. And as a result of that, we have some legacy sites. We have a very broad program: X-rays, radioactive materials, radon accelerators, and nuclear power plants. The National Council on Radiation Protection and Measurements has its roots back in 1928. Laurie Taylor, who I'm sure was a good friend of and colleague of Herb Parker, headed up the NCRP in the committees that led to the NCRP early on in the 20th century. And this quote from Laurie, I think, is really apropos. Radiation protection is not only a matter of science, but it's a problem of philosophy, morality, and utmost wisdom. And I really like this quote. It really sort of captures radiation protection. It's the sciences and the sort of art of implementing those scientific realities. And that radiation protection system has evolved over the years. We know we have lots of biological effects, and I'll talk studies which I'll talk a little bit about. Those biological effects and studies, we've developed standards and regulations. We want to protect workers, the environment, patients, and public. And we have this feedback loop of very sensitive instruments for detecting, say, contamination and radiation sources. But we also have the societal political influences, and that's something we always have to keep in mind as a regulator. And over the years, we've developed international recommendations. We want to justify, optimize, and limit radiation exposures under various existing conditions, planned exposure scenarios, and emergencies. And these are basically the international standards that have developed from 1960 to current. In Pennsylvania, well, actually in the United States, here we have many federal agencies involved in radiation protection. The EPA technically has the lead for radiation protection standards. They raise these recommendations to the president. The president issues an executive order, and all of the agencies are supposed to implement that. Here in Pennsylvania, basically the NRC is the regulator for nuclear power plants, and the Pennsylvania Department of Environmental Protection, Bureau of Radiation Protection, we do everything else. We do the X-rays, accelerators, radon, radioactive materials, and emergency preparedness. And our mission is to really safeguard public health and safety in the environment from harmful and unwanted, unnecessary, or inappropriate exposure to controllable radiation sources. And as you'll see, radium was not very well controlled in the early part of the 20th century. And it really wasn't until the 60s and 70s that the states began registering and licensing this material. And it really wasn't until the Energy Policy Act of 2005 that the NRC, or its predecessor, the Atomic Energy Commission, had control over discrete radium. Here in Pennsylvania, we've got numerous related statutes. Our primary statutes related to radium is our Radiation Protection Act and our Low-Level Waste Disposal Act. Interestingly, discrete radium, per the Energy Policy Act, is not low-level radioactive waste. And we could probably spend a whole hour on that. And actually, a lot of these slides, we could spend a whole hour lecture on a lot of these topics. But the exclusion there actually allows the states to dispose of radium in Washington State at the low-level waste disposal site up in Hanford. So we have a lot of regulations out there. If you ever can't sleep at night, I encourage you to go online, to download 10 CFR Part 20 of the NRC's regulations or our regulations. There's lots of regulations that will put you to sleep, but in all seriousness, they are important to protect the public and patients and the environment. Lots of standards, regulations, a lot of these regulations, radiation protection standards are codified in the regulations. Some are not, like radon, indoor home radon. We do not regulate the radon in people's homes, but we do regulate the people that test and mitigate in homes and schools and businesses. I have my major apology here to all the SI international units folks out there. We still at the grassroots level are working in conventional units here. So I'll be talking about picocuries and milligrams along here. So I mentioned we gained agreement state status back in 2008. Most of the states are agreement states. Wyoming just became an agreement state. Vermont just became an agreement state. Connecticut actually has a letter in to become an agreement state. This is where the NRC actually relinquishes their authority to regulate radioactive materials. Again, they keep the power reactors and the research reactors. However, even before we became an agreement state, we were licensing and controlling radium, and it gave us quite a bit of flexibility, and accelerator-produced radioactive material, which NRC didn't have the authority to do until 2005. About that time frame, the NRC had commissioned Oak Ridge to actually look at old historical radium sites. We in the other agreement states got a laundry list of various radium sites that they sort of called out of this historical review by Oak Ridge. And in fact, a lot of these sites we had dealt with, we knew about, and we had dealt with many sites that the NRC was not even aware of. We dealt with, and in that respect, as they rolled this out to all the agreement states, they actually asked the Pennsylvania program to join them in some government-to-government interaction with the other states on how we dealt with these old historical radium sites. And in fact, we have the flexibility with radium to implement various approaches to cleanups and as you'll see, which we have over the years, including the Uranium Mill Tailings Act, which was from the late 70s. We have the only 2 uranium mill tailing sites east of the Mississippi. So just a step backwards a little bit here, late 1800s, 1890s specifically, Crookes had developed a vacuum tube for generating these cathode rays. Rankine in 1895 discovered X-rays while he was experimenting with these Crookes tubes. Very quickly in early 1896, Becquerel discovered natural radioactivity trying to generate X-rays from uranium ores. And very quickly after that, the Curies discovered by separation of uranium ores chemically, they discovered 2 new elements, polonium and radium. This was a huge thing back in the late 1800s, early 1900s. The Curies, very dedicated scientists, became just superstars in the science world, which they really weren't looking for. They just wanted to do their research. Here's some pictures. Sadly, Pierre Curie died in an accident, hit by a cart in the streets of Paris in 1906. Left Madame Curie and her 2 daughters. These are just some pictures of Madame Curie through the years. During the First World War, she developed trucks for taking X-rays at the front. What I really want to point out here too is this photograph of a physics conference that Madame Curie. She really was a trailblazer as a woman scientist, extremely bright lady. Became good friends with all of these physicists around Europe and in the United States. And she actually came to America in 1921, her first trip to America. And this middle picture here is a piezoelectric device that she used in her studies with her husband, Pierre. And she actually donated to a museum, the College of Physicians and the Mutter Museum here in Philadelphia, which I'll talk about. Lots of accolades to Madame Curie and Pierre over the years. Coins, stamps, names of minerals are named after her. And she got I think it was the 3rd Nobel Prize in physics. She shared that with her husband and Becquerel. It actually got a 2nd Nobel Prize in chemistry, and again, unprecedented until probably the 50s, where one person got more than 1 Nobel Prize. Very famous scientist. I can't imagine there are many people in the field of chemistry or physics that don't know Madame Curie. If anybody's interested, I would highly recommend her daughter's book, her biography by her daughter Eve, that was published about 1937. Eve was not a scientist; she was a pianist and a writer, and again a real promoter of her mother and her mother's work. I'm going to do a shameless plug here for a meeting that my colleague Joel Lubenow and I are working on this next month is the 100th anniversary of Madame Curie's visit to the United States in Philadelphia, and on May 23rd, and you can go to the Mutter Museum's website or this link here will get you a free registration to this little seminar we're going to have on the afternoon of May 23rd. And if you have the time, there's a number of movies out there, Greer Garson, and there's a more recent movie which really was quite, I don't know how to describe it. The scenery and the acting was good, but the factual errors in this more recent movie, I don't know where to even start with that. But there is a lady out there that actually portrays a number of famous women, and Madame Curie is one of the ladies. She's actually this lady, Susan Marie, is an engineer herself, but she's been doing this, and I highly recommend. In fact, coming up this weekend is a presentation she's going to be doing as Madame Curie. It's really well done, and you can see some sampling of that in these links. Just Google Susan's name and Madame Curie. So what is radium? Where does it come from? We have uranium, naturally occurring, very ubiquitous in the Earth's crust, goes through some dozen plus decays, and along the way we get radium-226. There is also the thorium-232 decay chain, which produces radium-228, but most of the radium we're going to be talking about today is radium-226, the longer-lived. Radium-228's got a half-life of about 5 years versus 1,600 years for 226. Chemistry of uranium is interesting. It's an alkaline earth metal, similar to calcium, strontium, barium. So if you ingest radium like calcium, it's going to go to your bones, and that's a bit of a concern for any internal, real concern for any internal exposure. And you'll see with the radium dial painters, which are rather famous, why that is. So production of radium in the United States, actually the Standard Chemical Company that was started by the Flannery brothers back about circa 1910, 1911. They actually produced probably most of the radium up in the early part of the 20th century here in Pittsburgh. Again, Madame Curie, when she came to America 100 years ago, she came to get a gram of radium that the women of America actually raised. In today's dollars, about $1 million, but it was produced out in Pittsburgh. And this building here, the Flannery building at the time, was where the laboratories were. The operation that actually separated the ores, and it takes about 500 tons of carnotite ore and tons of water and acids and such to separate to get 1 gram of radium, was done in Canonsburg, just south of Pittsburgh. And here's a picture of Madame Curie in May of 21 visiting the Standard Chemical site. If you want to read a good history on radium, Joel Lubenow, good friend, colleague, and Ed Landa, just recently published a book on the history of radium in Pennsylvania, specifically Pittsburgh. And it's a free book. Again, you can Google a Radium City and Joel's name and get access to this book. Really good book. Interestingly, fast forward, this building, I'll talk about the Canonsburg site, but the building itself was discovered as radioactive about circa 1960, cleaned out then. Fast forward, the building again turned over in the late 90s. The new owner found out it was still radioactive, so we licensed that building in 1999 and got that down to bricks and mortar. And it was several $1 million cleanup, but it was a huge effort on the part of the licensee and their contractors. Canonsburg site itself, south of Pittsburgh, again became an Umptrecha site, Standard Chemical, which became Vitro in the 20s and 30s. A lot of uranium tailings, again, 500 tons of uranium ore to produce 1 gram of radium. There was a film back in 1982 on this. But again, the DOE came in the mid 80s, and Jim Yusko, who just recently retired from our program, probably recently about 10 years ago, Jim was the lead on this back in the 80s on closing that Canonsburg cell. And again, the radium that came, about 75 grams, came out of the Standard Chemical operation. Some sort of quack stuff, sprinkle radium on your plants, make them grow bigger. But there were some early applications of radium, and you'll see radium can be mixed with zinc sulfide to make luminescent material. Those operations started in Pittsburgh. But also the point I want to make here is, and this is their journal up in the left-hand corner of this slide, they did produce a lot of medical radium sources for cancer therapy. And in fact, this journal that they started, which ran from about 1913 to about 1921, they published a lot of the literature that was out there on radium and a lot of the really well done specifically, I'd call out the early brachytherapy for cervical cancer. That was an early success with the use of radium in treating and sometimes curing cervical cancer. And I just mentioned the American Radium Society started back in 1916, devoted to therapeutic uses of radium, and they're still out there. Yeah, I just want to go through a few slides here and show you some of the sources. This is typical of the typical needles that were made. You'd fill the radium, you'd encapsulate them with either glass tubes or platinum iridium metals. A lot of manufacturers out there producing these. You would produce plaques, you'd produce tandems and such, and mostly topical or sort of cervical. But sometimes you would implant these sources directly into tumors that you could access without great interventional surgical procedures. And just a few images from some early reference books. The Belgium group, where they had the Congo pitch blends to separate radium from, they brought all these pitch blend ores up from the Congo in Africa, which were much more highly radioactive concentration of radium. They basically put Standard Chemical out of business. But they produced a lot of radium sources for cancer therapy, topical type of plaques and such. And what I'm going to show you here is just some images of from this book. It's an interesting early 1930s book. And I want to point out, in addition to the topical surface treatments, they early on got into deep seated therapy, and they'd have grams of radium, and they called them radium bombs. And it was really the early beginnings of teletherapy, which we have today, in which evolved into, after the Second World War, cobalt-60 sources. And then once the large accelerators came into vogue in the late 50s, early 60s, we now have the large Linacs and such for therapy. But the roots of teletherapy really was with radium. And of course, again, as Wayne mentioned, Herb Parker, working with Patterson, produced a classic system for dosimetry. And this was key in the 30s, is getting accurate radiation dose calculations to that tumor, in that tumor volume. And this is a book I found about 10 years ago. It came apparently out of the Los Alamos Library. I'm not sure if I found it online or used bookstore, but again, it just sort of illustrates Herb Parker's sort of really early work in medical physics back in the early 30s back in the UK. And just a few slides here from Herb's book it became known as the Manchester system, where you could create arrays of these sources, and through the math and the geometries, get uniform radiation dose to that tumor volume. And again, Herb did an amazing job in these calculations and such. And here's some images of those sources actually on a patient, some X-ray photographs of X-ray images. And what I wanted to point to also, the photograph D here, is these seeds, these radon seeds. Radium was very expensive up until the 30s, when the Belgians and then the Canadians came in with more productive ores. But these radon seeds, they would build these plants, and they'd have several hundred milligrams of radium in a plant, and they'd milk off the radon gas, which was a 3.8 day half-life, but had a lot of gamma rays. And they'd put them into these gold seeds, these little tiny gold seeds, and actually use them as permanent implants. And I remember early in my career at Medical Center in upstate New York, I was probably involved with the last radon seed implant at Albany Medical Center back then. And they quickly evolved in the late 70s, early 80s to these I-125 sources for permanent implants. Excuse me. So back in the 30s, again, to stick in the 30s for a moment, the cancer treatment at the time, you basically had X-rays, external X-rays, and some of the higher energy beams were starting to come along up to 250 keV or so in some mega voltage machines, but not many out there. So you basically had these X-rays, radium, and then surgery for treatment of cancer. And interestingly, and I just came across this over the weekend, radium treatment. There was a bit of a turf battle, apparently, and you can picture this between physicians regarding surgery versus treatment with radium. And interestingly, this one surgeon was writing in Nature, leave the radium in the bunkers there, protecting it during the war. But this guy Sidney Russ responded, no, there's great opportunity here for radium and X-rays. And just a little bit into the quackery, and actually this article I found years ago in this Science Mechanics back in 1932 is where I sort of co-opted my current title for this presentation, Radium, Miracle or Menace. Again, there was a lot of, and I want to say quackery, but it was actually the AMA in the teens and 20s actually bought into some of this. There was a lot of radium waters out there. You'd sit in a room, you'd breathe radon gas for treatments. That all went away, and I'll show you in a minute where that went to. There was, again, radium was just a huge issue, and there was a lot of products out there that would put radium on, like beauty products and such. There was dances and sort of dance shows, the radium dance. You can actually listen to this music online. There was actually products like lights. This group out in somewhere here in where were they? Pittsburgh produced the Radium Light Company. There was no radium in these lights, but they put radium, and they did this with X-rays too, just on the product name to push the product. Again, the waters. Here's a physicist from Temple sampling water. They found Fairmount Park. Some of the springs out there had high levels of radium. I don't think they were very high, but they had detectable amounts of radium in those springs. And if you really want to, and this is a shout out to Paul Frame, good friend and colleague. Paul has built just an incredible website on HBS, health physics instruments, and some of the quack stuff that's out there. And the ones I'm showing here are just Pennsylvania. And they were all sorts of devices and things you could make radioactive and drink or eat. Again, back in the early teens, there was a concern because a lot of the radium was going to Europe. Standard Chemical and others were shipping carnotite and radium out to Europe. And there was a big investigation, congressional investigations and such. And they were looking for sources of radium other than Colorado. They found that here in Mount Chunk, Pennsylvania, which is now Jim Thorpe. They found a rich vein of uranium carnotite ore out there. They never did mine it in the teens. Fast forward to the 50s, they did mine some of it, but those mines were closed in the 70s. They never really produced much uranium. But this fellow Kelly in Baltimore was really interested in producing more radium. And again, the second wave of the uranium boom was the 50s for all the weapons production. You folks are out in Hanford, Richland area. The feed material for the plutonium production was uranium or uranium metal. And so back in the 70s, there was actually some flyovers. A colleague of mine, Bob Smith, who's retired from Pennsylvania DCNR, really outstanding uranium geologist. These flyovers, you can see these maps out there on the USGS. You can see some hotspots in Pennsylvania, Colorado Plateau. And interestingly, if you ever get to the Air and Space Museum by Dulles, you can actually see a Piper Cub that was built in Pennsylvania that the Atomic Energy Commission used to survey the United States for uranium. Yeah, I'm just going to go quickly through these. Lots of universities were doing geologists, chemists. This was kind of sad. Some of these uranium samples, really beautiful bottles, and had a beautiful display. No real exposure to students or staff there, but they wanted to get rid of all this, and we helped them with that. These turbinite jars up in Allentown back in the 20s, they were basically bringing turbinite ore from New Mexico up and fill in these clay jugs. You'd put water in there, infuse it with radon, and drink it. And Joel Lubenow, I think, actually surveyed this back in the 60s. Then we had another fellow go through just probably about 10, 15 years ago. Some of this group was actually out of Philadelphia, but we think these clay jars were produced in New Jersey. Some of these, you don't see many of them at all out there and on eBay. So I've never seen one of these. This is off of Paul's the website. This one I've never seen. We do see some old ads and such for this. But again, you'd put a source of radium in there, and you'd infuse the water with radon and drink it to cure what ails you. This thing, this group out in Pittsburgh, this Parr Laboratories, never saw until I saw this this jar for sale on eBay several years ago. The building where they were producing this came down. It's an old bank building, so we couldn't even go in and look at the facility. These tablets were produced again in the Pittsburgh area. I think there was maybe some trace amounts of radioactivity in these tablets. But this one is the real interesting one. This guy, Evan Byers, was a rich industrialist from Pittsburgh. He fell out of a berth on a train going between Yale and Harvard, some football game, injured himself. His doctor prescribed this Radithor, which was produced by this Bailey guy in New Jersey, which actually was distilled water with a microcurie each of radium-226 and 228. Byers drank several of these a day until his jaw started falling apart and his skull, and he died a miserable death. And this was actually the case that brought the wrath of the FDA down on a lot of this quack radium stuff. But you'll occasionally see these little jars on eBay. They're most hopefully empty. We came across a couple cases of these empty jars some people were cleaning out their parents' house. The kids had no idea if their parents drank these or not, but hopefully not. But fast forward, they still had this sort of these homeopathic bromides. Again, this is John Vilforth checking in the 60s. He was with the FDA. They put a tincture of uranium or radium in these things. And here's John and a colleague from the FDA sorting through boxes of these homeopathic jars. These are really interesting. This is now, again, outside of Philadelphia. Philadelphia would recycle radium sources. Again, radium was valuable. Fast forward to the 60s, they discover this house is extremely contaminated. Public Health Service, that's John Vilforth in the lower left, being surveyed out. And Tom Jaruski, one of my predecessors, got this house pretty well cleared out in the 60s. There's actually a film out there. We have a 16 millimeter film of this. They brought the Air Force in. But fast forward, this in addition to this house and this neighborhood, this W.L. Cummings site, which is in the background of this wonderful Negro League photograph, these guys were producing radium nearby and outside of Philadelphia and Lansdowne. And this actually turned into a rather large cleanup. EPA came in under Superfund. Bill Ballinger led that effort back in the 80s and early 90s, and millions of dollars cleaning up this neighborhood. Fast forward to the 90s, we sort of rediscover another radium operation in Sellersville. This group produced radium for a short period of time, a couple grams of radium, and went out of business. The building was then became this U.S. gauge, and they actually painted dials on gauges with radium. That was actually, I think, a $6 million cleanup of this landfill back in the mid-90s, just before I got here. This one sort of resurfaced. This is the old Keystone Metal Reduction out in Cheswick, just north of Pittsburgh. We sort of knew about the site, but we didn't know where exactly they were, and found a map and actually surveyed the property. This one's in the process of being remediated. Fortunately, there's no exposures to anybody. All the ores are underground, and there's no groundwater contamination from the ores. The radium dial painters, and I'll go quickly here. I'm sure many of you are familiar with the Radium Girls, the New Jersey cohort, or the most famous cohort, where they would paint radium with zinc sulfide onto aircraft gauges, clocks, and watches and such. A very famous case, and we could spend weeks on this. That U.S. radium actually moved to Bloomsburg, Pennsylvania, and 1948 they bought a toy factory up there. They were still working with radium into the 70s. In this photograph on the left, I found on eBay years ago, they actually did radon breath analysis on a lot of these women. And in fact, Victor Hess, who discovered cosmic rays, was a consultant to U.S. Radium over the years. Hamilton Watch, a little closer to where I am here in Elizabethtown, Pennsylvania. Hamilton Watch in Lancaster, they also did a little bit of radium painting down there. We walked all these. It's now condos. We walked all through the school and such, and really didn't find anything. Very clean operation. This is interesting. Back in the late 30s, early 40s, the program that developed into my bureau actually surveyed radium dial painters, again, up in Sellersville, this U.S. Gauge operation. And I think it was the Ottawa, Illinois cohort, the poisonings this case was being played out in the late 30s up in Chicago, precipitated this. So and Sergey at the registry helped me. I actually interviewed one of these ladies, and we were able to track down her records. Sergey was for me, and Dick Toohey and I had a nice conversation with the daughter. And she actually worked in the shop, this Bendix Aviation outside of Pittsburgh, about the huge facility painting radium. These guys produced thousands and thousands of aircraft gauges during the war. Again, our Southeast Regional Office, we walked this entire complex and found nothing. But interestingly, a fellow by the name of Frank Willard, during the war, was out there measuring radon, doing radon breath analysis, and correcting any problems in some of these radium dial paint shops. And he printed this, he published this article in '46 of some of that work in industrial medicine. And as we all, hopefully most of the health physicists online know, MIT, Robbie Evans out at MIT studied the radium women, the dial painters and such for many years. That work went out to argon and basically is the basis for a lot of our internal alpha emitters now. If you want to read a good book, there's lots of books out there on the radium girls. Claudia Clark's scholarly treatise on this. And if you want to see a good movie, or skip the movies on the Radium Girls, if you can find D.W. Gregory's play, The Radium Girls, really, really well done play. And I can't not mention Frank Hartman, who was a radium salesman in the 30s and 40s and 50s in Pennsylvania, and the Philly area. But he would track down lost sources. They had a radon seed plant blow up in the American Oncologic Hospital back in the late 40s, cleaned that up. But all his diaries are over there in the Mutter Museum, the College of Physicians, and the records. Really interesting reading. All the lost and found radium that he had done in the 40s. Probably one of the first real health physicists, and he would require the physicians to know about radiation before he'd sell them radium. Of course, John Vilforth in the 60s was very concerned about all the problems and the control of radium, and that's when the states started looking at this. And again, my colleagues Tom Jaruski and Joel Lubenow back in the 60s were out there looking at the various facilities in Pennsylvania here that were utilizing radium and starting to get our arms around control of that. And even just this little caper, Bill Ballinger from EPA Region 3, they found a source, came out of a file cabinet, it came from New Jersey, at a metal recycler, and that source actually came from a facility in Philly. So during the evening, I think they had the RAP team in, they were going around all these offices in Philadelphia looking for more of these old radium needles. And interestingly, this mostly up in Buffalo area, but these gold radon seeds were recycled, and you can kind of see a line in this class ring, and you actually had them. This ring became radioactive because there is some long-lived lead-210 in these seeds. So this was a problem, and New York State was really out in front. But we had some of these here in Pennsylvania, Pittsburgh area. And of course, we're the only state that requires landfill monitoring. The things that we see show up at a landfill, glow-in-the-dark crucifix, radium needles, calibration sources, check sources, electron tubes. That source in the lower left came out of a college of physics lab cleanout. It's actually a radium beryllium neutron source with the paraffin moderator. This item up in the far right, upper right, is a radium I can't even pronounce it, a radio indoctrinator. You were supposed to tuck this near your male parts when you needed some vim and vigor. Had probably about, I think, 100 microcuries of radium in it, really hot items. deck markers, static eliminators, gauges on trucks, old types of smoke detectors, industrial sources. We've seen it all. On top of a mountain several years ago, we found a system that was used for high vacuum testing back in the 50s, 60s. And yeah, it was just sitting next to a cell tower on top of a mountain. Somebody was up there hiking, found it. We went up and retrieved it and got properly transferred it for disposal. We budget about $30,000 a year for these orphan sources. Industrial radiography in the industrial side, radium was really huge, especially during the Second World War for checking welds and castings and such. And they didn't have a lot of big X-ray machines for doing this, so radium was the source of choice. And that's evolved. And even during the 70s, before they moved the Liberty Bell across the street out of Independence Hall, they did a bunch of industrial radiography. And Vince Rotting, God bless him, just passed away, was industrial radiographer who did all this work, was on my advisory committee for many years. He claims he was the last one to ring the Liberty Bell with his head, placing all this film and such. But in all seriousness, the welds on pipes and tanks and such, very important. And today we use iridium-192, cobalt-60, and X-rays for this work. But unfortunately, we occasionally find these old radium-sized sources. Back in 2016, we found a 100 millicurie source, and hopefully, I think we gave this to Oak Ridge for recycle for radium-223. You can actually radiate 226 for radium-223 production. But yeah, this was quite a caper. And this is actually the caper of all capers. This showed up at a waste transfer facility 3 blocks from our office in Norristown, Pennsylvania, a curie of radium. This thing was screaming hot. It was setting off an alarm like 4 or 5 trucks back. It was clearly old brachytherapy tubes that were actually manufactured circa 1920 out in Pittsburgh. So we worked very closely with a number of people and got this all packaged up, and again transferred it hopefully for use for production of radium-223. Sadly, recently some radium needles got through a detector at a scrapyard outside of Pittsburgh. And the operation managed to contaminate a lot of scrap metal and such, and a facility got transferred to Ohio. So we had a couple of facilities in Ohio and Pennsylvania. Very costly cleanup and shutdown, loss of business for this operation. So you see these radiation detectors on all the metal recyclers and a lot of the landfills. And it was actually a landfill alarm that keyed us off to this operation up in Lock Haven. These folks were refurbing and testing and rebuilding aircraft gauges up by the old the Piper Cub facility. They were scraping the radium off, and that led us to them. We got them all cleaned up, and actually the building got moved, and they got the building tore down. They had operations across town. It turns out they evolved out of this Carnish operation back in the 70s, and so there was this Ron Reynolds facility that had taken over the building that was grossly contaminated. Again, we decontaminated that, basically knocked the building down, and put an alert out for anybody that may have these old aircraft gauges, because this was really problematic. And technically, at this point in time, they had to be licensed. So this was the cleanup, and just recently finished this up. We actually had to move some elderly women. There was an apartment across the way where all the radium, scraped off radium, was dumped in the back. So all the soils were contaminated. Just big operation, millions of dollars to clean this up and relocate people. Minor situations when they were knocking down some buildings at Harrisburg International Airport, and that you can see 3 Mile Island in the foreground there. They found a little bit of radium contamination there. It used to be an air base during the war. Same over outside of Philly, another little trailer that had some minor radium contamination that we dealt with. But the mother of all loads were was probably the Struby operation in Lancaster County. Eight sites, 8 buildings with probably about 1 million aircraft gauges just stuffed all up and down in these buildings. A lot of it without fire protection. And at the end of the day, the EPA came in, about 400,000 aircraft gauges, radium aircraft gauges. They screened all of these and shipped them all out under Superfund. It was an emergency removal. EPA Region 3 was very helpful with this, and we really thank EPA for all their support over the years. And getting towards the end here, a lot of this material, when U.S. Radium moved out of New Jersey, they moved into Bloomsburg, and this is an aerial view back circa 2001. All the buildings are down. EPA got this on the Superfund list, and just a few years ago got some of the waste dumps that were in these old canals along the river. So there's still a lot of soil contamination, but the immediate threats are gone. And you can see the neighborhood, it's right across the street from residential homes here. And I just got a quick sidebar on the smoke detectors. These are old industrial smoke detectors. Initially, they were radium-226 foils, and we saw a lot of that come out of the old U.S. Radium site up in Bloomsburg. But when you think about the probably thousands and thousands of people's lives that were saved with smoke detectors. Of course, now we use a small quantity of americium-241 as the source for ionizing the gas, the air for these smoke detectors. But this really, I mean, radium again was one of the early materials used for these smoke detectors, and really, thousands of people probably saved lives during fires. Just a quick on radon. Again, as you probably remember from that map, the flyovers of Pennsylvania, we have rather high natural radium in our soils and rocks. There were no standards until the 80s, until a fellow by the name of Stan Watrous set off an alarm at Limerick Nuclear Power Plant. His house, which we refer to as the index house, had about 2,600 picocuries per liter. They got that down below 4. This is Stan and his family, circa 1984, and just some maps of Pennsylvania. So this is what really started the indoor radon concerns. And we still have issues, and we're still concerned about it. In fact, just about 5 years ago, a brand new neighborhood south of Allentown discovered another house being built that actually exceeded the Watrous house, the index house. And I actually went up, it was a Saturday morning when they got this house, they got it down below 3 picocuries per liter. We actually recommended the family move out of this house. It was a brand new house. They'd only been in there in a few months. And in the whole neighborhood, they're all these beautiful homes. As we started looking at these homes as they were built, we got about 19 houses that were over 1,000. One was over 17,000. We think we've got a world record as far as indoor radon levels go. But that's the bad news. The good news is, got most of them, the vast majority, down below the 4 picocurie per liter action level. And I really have to take my hat off to my radon division, Bob Lewis, Denise Blyler, and all of the staff that have worked so hard over the last 5-6 years working with the builders here. So just switching gears a little bit as we're coming up on the hour, oil and gas, this lower left photograph here, we actually started the oil industry in 1859 with Drake's Well. So the conventional oil and gas industry has been out there for years. We actually looked at NORM and TNORM back in the 90s, looked at the return produced water, as it's called. But as things started, the uptick, we're actually sitting on probably one of the largest reserves in the world of natural gas in these Devonian shales, this Marcellus shale. And you can see this shale in Pennsylvania, West Virginia, and into Ohio. You got the Utica shale below that. And you can see the black shale here in the lower left. But this is where I'm sure you've heard this term, hydrofracking. And again, we could spend hours on this subject. But we did look at this, and you can see this is a natural gamma ray log of Devonian shale here in Pennsylvania. And they actually they look at the natural radioactivity in the shale, because when they go horizontal, they want to make sure they're in the higher areas where the organics, and they find a correlation between the organics and the natural uranium when it was precipitated some 400 million years ago. So when you treat those processed waters, those produced waters, and frac water, you get what we call technologically enhanced naturally occurring radioactive material. These sludges have to be dealt with as they were with the conventional oil and gas. So we've done that, and again, we can spend hours and days talking about T-norm. If you're interested in our T-norm study, we just finished a big T-norm study back in 2016. Still doing some follow-up on that. Really great work. Andy Lombardo and his staff with Permafix helped us out with that. But kudos to, again, Bob Lewis on the radon side and Dan Husted and DEP, who really sort of led the effort in getting all the sampling and done into our lab. And if you want to really read a good report, the NCRP Commentary 29, which Bill Kennedy just finished up and has on the street on if you're interested in T-norm. So this is, boy, my wife's upstairs watching this, and she's probably just scratched. Can't believe I got this done in an hour. So, so medical therapy. I just wanted to sort of end with this, and again, sort of reflecting on the early uses of radium for topical and then sort of teletherapy, the radon seeds. All of this has evolved. We now have big Linacs for photons, electrons. Over UPenn, we have a proton machine. In fact, Lancaster is going to be getting a proton machine. All this really high tech. The brachytherapy that was initially radium, I remember in the mid-70s, we changed over our radium needles to cesium-137 at the time in the mid-70s. Kept one of those radium needles for a calibration source because we had NBS traceability, but that's evolved. It went from radium to cesium-137. Now we have iridium-192 brachytherapy, much faster delivery, and much lot more precision there with these brachytherapy. And again, the radon seeds have now been supplanted by no pun intended with the I-125 and the palladium-103 sources and such. So. I just want to kind of end here and just note that the discovery, production, use of radium impacted the health of many workers. These radium dial painters, for sure, probably tens, dozens of women, whoever drank this quack radium waters back in the teens and 20s. But when you look at the evolution of the use of radium through the years and the treatment and in palliatively and cures for cancer, it's real, and its use in industrial radiography and other uses of radioactive materials. Again, I'll pose the question: is radium a miracle or a menace? And my conclusion is it's the scale is really tipping to the miracle side than the menace. So I am going to stop there, and I need to give a big major shout out to and some of them may be watching, all the folks I work with in the central office and region. This was our last hands-on meeting. I really miss these folks. They're the ones that are out there doing all the hard work, overseeing the cleanups of these sites, investigating all the issues with X-rays and accelerators and radon. Oversight, emergency response with our nuclear power plants and decommissioning of those plants and such. And they're really wonderful people, and I really feel honored and blessed to be sort of steering the ship here in Pennsylvania. We do these all hands meetings once in a while. We were supposed to do one in April of last year. Sadly, had to cancel that last minute, and hopefully we'll get to do one as soon as we're back. Here's my contact information. And I'm going to stop there, and hopefully that was all clear. And I'm going to give a shout out to Matt or Wayne, if you guys are out there.
Dave, I want to thank very much for what I consider to be a very fascinating lecture, particularly the history of radium and the role that it's played in developing radiation protection or lack thereof in the early days. I think it's always important to understand how we arrived where we are and what things played a major role in developing what we consider to be modern health physics. Certainly looking at the radium that you presented here, played a critical role in the early years. And so I think it's important for all of us who are in the field to understand that and recognize the importance that radium and, as I said, its control or lack thereof played in the development of modern health physics. I'll take the privilege of being a moderator, if you will. I have one question, and in the long litany of radium cleanup and radium discoveries, if you will, you found in the state of Pennsylvania. I started my career in a naval shipyard.
Yeah.
I know you talked about airline gauges and airports and such. We had several significant incidents, if you will, at a naval shipyard regarding an instrument calibration or instrument maintenance laboratory that had very large old oak wooden floors. And we started surveying and found that the radium was literally everywhere. We tried to plane these old 2-inch thick oak flooring, couldn't get it done. It seeped in down into the cracks and crevices, and we literally had to tear the whole place apart and send it all off to waste.
That picture of the Flannery building. I was just going to say that picture of the Flannery building, that 5-story building in the Oakland area of Pittsburgh, exactly the same. They had the floors up, the wall coverings down to basically the girders and the bricks, and it just went everywhere. Yeah.
Well, my question, I guess, I was leading to a question. Have you had any incidents or found any radium hanging around a naval shipyard? I'm thinking of Philadelphia.
Interesting you should ask that. Actually, we had some records, and I am sort of the liaison to the Bettis Atomic Laboratory outside of Pittsburgh. And my DOE counterpart out there, I actually relayed some information to him, and he had some records. And they did, actually, just interestingly, I think recently they did find an old building on the Navy Yard that had some sources in drawers and stuff, small check sources, but nothing major like that.
Well, that's good, because we found when we were doing work at the shipyard that a lot of the, I'll say, original scrap from radium dials and such that they had cleaned up were put in barrels, taken across Puget Sound and buried at the end of a naval air station over adjacent to Seattle, which we had to go over and dig them all up. So you never know when you get some of these leads where it's going to lead and go to. We do have another question that's come in. I thought at first perhaps you dazzled your audience to the point where they couldn't think of anything to ask. But we have a question. Have you run into any interesting public information challenges with certain cleanup sites? Dealing with the public.
And dealing with the public, this Struby site was interesting because a lot of these warehouses and such were actually in Marietta, the little town of Marietta down in Columbia. And we had a lot of we've got public relations folks, communications folks in the DEP, and they helped us a lot. And we worked closely with the emergency responders. We work closely with PEMA for our power plants. We've got 5 nuclear power plant sites. So we had a lot of good communications with the emergency responders as we worked through this. And my department secretary at the time, Katie McGinty, she was very supportive, and we really worked through all those public relations issues. And yeah, it's always a challenge. People are always afraid of radiation, and it was really just the fire scenario that we were really concerned about. And we actually established some security in these buildings as we were cleaning them out, just so they wouldn't burn down.
Have you had any other or any continuing issues with radons in homes? You mentioned the housing development where they had such high levels. Is that still something that people are concerned about? And I'm thinking of realtors trying to sell homes or building new developments, et cetera.
Yeah, Pennsylvania, as I mentioned, is we have 67 counties, and 66 of those 67 counties do have high potential for radon. So we're working very closely. Believe it or not, we don't have requirements to test and disclose before sales of a home. Nor do our schools have to be tested. West Virginia requires every 5 years their schools have to be tested. And radon-resistant new construction's a big issue, and we get out there and we try to promote that, but it's not required. And we're actually working with the fellow that's the head of the building code group right now, trying to get this voluntary Appendix F in the building code. It's just it really doesn't cost much to put in some PVC pipes and such as you're building a house and laying the foundation and the slab that you're going to be building on ahead of time. But if you got to afterwards drill holes through the concrete and put in the active mitigation system, that's where it gets costly. So we're pushing for three things, and I'd like to hopefully get it done. It's on our department's legislative agenda this year. Radon testing and disclosure, testing in schools, and radon-resistant new construction. But to answer your question, Wayne, yes, given our soils and rocks and such, this area below Allentown, it wasn't even this famous Redding Prong area. It was called the Epler Formation, which was this fractured dolomite, which somehow had, our geology consultant, Bob Smith, knows all the details, but somehow all the uranium got into solution and entered this dolomite, and then it became fractured, and that's what's causing some of the soil levels around these houses are up there, So that's we continually work it.
Well, while we've been discussing the radon, a question has come in regarding the radium dial girls. Are you aware if any of them are still alive?
Well, that one radium dial painter, not any in Pennsylvania. There was one or two that we tracked down out of Hamilton Watch, and this lady that worked over in Bendix, her daughter contacted me. She was looking for her mom's records from she thought Argonne. Actually, the mom had gone up to MIT. So again, through Sergey and the registry, Sergey was able to pull the lady's records from microfiche, and again, Dick Toohey and I. But I actually went over, after Dick and I talked to the daughter, my wife got a nice little plant, and I actually went over and interviewed the lady. She was about 89 years old. This goes back about 6 years now, maybe longer. But spent a wonderful couple hours with her and her daughter and son-in-law. And she described working in this Bendix facility that, and by this time in the early 40s, they knew, no touching of brushes with your lips. It was all sort of silkscreen kind of operation. But she did mention it was like painting at a salad bar. So they had glass in front of the operation, probably similar to what we saw in that photograph in Frank Willard's paper there, but yeah, I did have a nice conversation, but I'm not aware of any. When you think about it, the 30s and 40s, I think she passed. She was like 90, 91 when she passed, but they're probably all long past.
Well, like I said, it's an interesting part of our history.
At this point, I just want to raise anybody who's got a glass of wine. It is 9 o'clock at night. If anybody's got a glass of wine or tea with a shot of Zambuca, I thought I'd raise a glass to Herb and a toast to Herb Parker.
Oh, I appreciate the plug. One of the things, and since you started it, I'll go ahead and embellish it, if you will, a bit. The Parker Foundation was basically created to memorialize Parker's accomplishments at the Hanford site and going forward through the Hanford laboratories. One part that we have not spent much time focusing on is his career, both in the UK and in Seattle prior to coming to the Manhattan Project. As you mentioned, and I'm well aware, is that he had a pretty illustrious career in terms of medical physics and use of radium for teletherapy and for therapy in general. And that's something that I think the Parker Foundation needs to focus more on, is those were the roots, if you will, for Herbert M. Parker prior to coming to the Manhattan Project.
Interestingly, Wayne, I was just going to say, when we were cleaning up an old research reactor up above in hot cell facility above State College, the old Queehana facility, which was part of the Atomic Energy Commission's atomic powered aircraft program, and they were doing snap generators up there. I actually found, and I got to try to dig it out, and I'll if I can find it, I'll send it to you. I think Herb signed off on 6 million curies of strontium-90 to come to Pennsylvania for the production of these snap generators back in the mid '60s. So I remember seeing that somewhere. I've just got to dig it out.
Our gift to you.
that was a $30 million cleanup. Thank you, Atomic Energy Commission.
More about history.
Yeah.
Well, I don't see any more questions. I do want to thank you again very much, Dave, for I think a very fascinating and interesting lecture. I'll let those who are still listening that if they have any follow-up questions or have any questions about the Parker Foundation, hopefully the information, the link to our website, the link to myself, if you have questions that you'd like to ask about the Parker Foundation or about Parker's life and legacy, please feel free to go to the website or send me an email, and I'll try to answer it as best I can. If there are no more questions out there, and I'm not seeing any coming through at the moment.
I was just going to say, Wayne, I really again appreciate the honor. This is truly an honor to do this Parker lecture, and I hope to be out with you at some point for one of these. Again, lots of good friends out there, and I just wanted one more thank you to my wife Marty upstairs. She's my rock, and who's put up with me for almost 40 years with a lot of this fun history stuff. But she's really supportive of a lot of this. So thank you, Marty.
Well, and I want to give thanks as well to all the people whose faces you haven't seen during this presentation behind the scenes. When COVID struck and the pandemic shut everything down, we were concerned as to whether or not we're going to be able to continue our lectures. Being able to do virtual lectures has opened us to actually a whole new broad audience, and has allowed us to maintain the legacy of our lectures and hopefully continue to do so moving forward. Relative to person, hopefully by this fall, we will have another lecture this fall. By then, hopefully restrictions will have eased enough that we can have person to person, but I think we'll likely continue virtual lectures as well. Thank you again, Dave.
Thank you, Wayne.